Hi everyone, welcome. My name is Jianmin Qu. For the past 5 years, I have been the Dean of the School of Engineering and the Karol Family Professor in the Department of Mechanical Engineering. I would like to thank you for taking the time to join us today for a fascinating look at how artificial intelligence solutions benefit humanity, featuring Professor Karen Panetta. This webinar is part of the series, A Force for Good, Tufts on the COVID-19 pandemic, which seeks to highlight the positive impact our faculty and the research are making during those unprecedented times. Before I introduce Professor Panetta, I would like to give you a brief update on what is happening in the School of Engineering. When the pandemic struck the US back in March, our engineering community immediately mobilized. Students worked to repair desperately needed PPE and to transform our no-lab makerspace into a workshop to create new PPEs for healthcare workers. Our faculty developed a temperature monitoring system in partnership with local communities so our most vulnerable citizens could be diagnosed and treated in a timely manner. When classes needed to be online, our faculty didn't just think about how to teach online, but came up with creative pedagogies that are as effective as in-person teaching, and then shared those with the fellow Tufts faculty, as well as the greater community, so everyone could benefit. I can't tell you how proud I am of our faculty and staff for their dedication to Tufts education and research mission. Also, I have been tremendously impressed by you, our generous alums, parents, and friends. Faced with the pandemic, you did not forget Tufts. You have continued your support when we need it the most. Your generosity helped us in so many ways this year, supporting our students so they could continue their education at home, supporting our faculty so they could continue as great teachers, mentors, and innovators, and support the School of Engineering so we can continue to be one of the best engineering schools in the nation. Your unwavering support allowed us to be truly an engine for good. I'm so grateful for your gift. What I'm excited to share next is one example of the impact your philanthropy. Professor Karen Panetta, whom I will be introducing shortly, is one of our most sought after teachers and a world-renowned researcher. She's also a direct beneficiary of your generosity. After hearing her work, I know you will feel proud of how your gift have truly made a difference. Karen is our Dean of Graduate Education and a professor in the Electrical and Computer Engineering Department. She is also an IEEE Fellow. She joined Tufts in 1994 after a successful industry career at the Digital Equipment Corporation as a principal engineer, where she developed the world's first digital twin capable of running software programs on a conventional processor. Karen has been recognized with numerous awards. Most notably, she was awarded the nation's highest award for engineering education and mentoring by President Obama. She went to the White House to receive the award. Karen is a visionary leader, both here at Tufts and around the world. She holds prominent leadership positions in the IEEE Society, including the president of IEEE HKN, the Engineering Honor Society, vice president of IEEE Systems, Man and Cybernetics Society, and vice president of IEEE USA. Karen is someone we can all emulate, collaboratively by nature, innovative in spirit, and focused on making a difference. Today, she will speak about how her artificial intelligence solutions benefit humanity. Now, before we begin, here are a few housekeeping matters. This meeting will be recorded and uploaded to our Tufts alum YouTube channel. You will notice your audio and video are disabled, but I would like to encourage your participation. So during our audience Q&A sessions, please submit your question using the Q&A chat feature at the bottom of your screen. Karen, the microphone is yours now.
Thank you, Dean Q. It is my pleasure to be with you here today, and I want to thank you for taking the time out to be with us. I've been at Tufts quite a while now, and I love being here because I love the innovation and excitement of watching students grow and flourish in their own careers. And one of the most impactful ways to do that is through our research, and getting them involved in that. So all the projects you're going to see today, I get the credit right now, but it's not me. It's really all about the teamwork and the fabulous students that I have on my team. So if you go ahead and put up the slides, we're ready to go. Amanda, do you see the slides yet? There we go. That's great. Go to the first one though. All right, you can go to the second one. Today, I'm going to talk a lot about AI, but I want to first start out by, what does artificial intelligence mean to you? Because everybody has their own different perception. A lot of it comes from science fiction. So we'll talk a little bit about that. So computer systems that mimic intelligent human behavior, that's one that's probably a standard definition for people who just get into AI. But we hear a lot about computer systems that perform better than humans. Are they computer systems that assist humans? Are they computer systems that don't need humans at all and they can take care of themselves and us and do everything better than us? And are they going to be systems that can evolve and overtake humanity? These are some of the things that you might have heard. I have a definition. You can go to the next slide. I have a definition of what I call AI. I believe it's to help humans, assist humans to explore, explain, and expand our capabilities to benefit humanity. And that's going to be the thrust of my talk today. So one of the things, the underlying foundations of all my research is it's inspired by real world events. And unfortunately, a lot of it's been by catastrophes and disasters that we see every day in the news, whether that could be due to natural disasters or some, man-made sort of disaster. So on the left here, you see this was the Therac 25 machine. This was operated by a computer from my former computer company, but the software program was written by a third-party vendor. And then there was this X-ray machine. And what ended up happening was that 6 patients were over-radiated and killed. And the problem became because no one had ever looked at testing, the computer always designed for things to happen for known test cases, but nobody ever tried to break it. And so, well, what happens if I hit keystrokes that aren't supposed to be hit? And there was no lock or threshold mechanism on the X-ray machine to prevent it from ever being, over-radiating patients. So there was nothing to lock it out. And because of these 2 factors, people died. And it took a long time to diagnose that. So that was the foundation of my research. But on the right-hand side, we saw after the earthquake, there were tsunamis. And this happened to be the nuclear power plant disaster. And one of the things that I looked at was, how there are human beings going in to look at these things, and they're putting themselves in danger of radiation, and the firefighters and first responders that are going in are also subjecting themselves to harmful chemicals. So now we know that we can use drones and things like that to go do these types of projects. So if you move to the next slide, I'll show you how we decided to move our research. So my first venture into AI was looking at some common problems that I see all the time. And I said, well, skin cancer is something that's, if you catch it early, it really can mean a lot to have early intervention. But so many people let it go because they don't go to the doctor. So I said, why not build an AI engine that I can take a picture of some mark on someone's skin and then have it diagnose whether or not it thinks it's cancer or not. So we go ahead and built this engine, and I went and I ran it on the common databases that were out there. And we came up, there are things out there that classify, yes, it's cancer, no, it's not cancer really well, and could say, yes, 99 to 100%. But our cancer detection can classify among 8 different types of cancer, and that's with a 98% accuracy. So one of the things that I decided on was, well, why I can take this engine, why can't I plug it into multiple applications and solve lots of world problems with it? So one of the issues with anything that we do medical, again, we're engineers, we got to work with great medical professionals across the Tufts campus, was anything you do a diagnosis on requires federal administration drug approval, and that could take up to 5 years. So we can't just create this app, put it out there for free and say, here, go ahead and you can use this detection. So I looked at this and said, well, how can I still use this as a learning model? So what I decided was, let's go, look at different types of cancers, whether it be oral cancer, skin cancer, or any other type of cancer. Like now I'm working on cervical cancer. So let's move to the next slide and you'll see what we did. So I partnered with Dr. Aruna in the School of Dental Medicine. And one of the problems that she's having is she says, I don't have enough time to sit next to a student and show them, here's what I see, here's what you missed, or here's what the different types of identifying the different types of deficiencies, or, are doing a diagnosis. Furthermore, there's so many people out there that send in radiographs expecting experts to look at them and screen them for them. So they're being taken everywhere all over the world, but they might not have the capacity to analyze them themselves. So what we built was an expert system that can look at input images. And the goal was for me to make an artificial Dr. Aruna, which meant that I wanted to capture her expertise on analysis so that we could use that then for training. So I used eye trackers, because right now a lot of the diagnoses that are out there are, yes, it's cancer, no, it's not cancer. And what the AI doesn't tell us is, well, what do you see that makes it cancer? So it's not explainable. And that to me is really important. And I learned that the hard way, because when I would have a false detection or an inaccurate result, I'm not a medical professional, but I'm looking at these things saying, well, why isn't this cancer? What did it not find? What's it missing? What kind of features are not here? So we created this system, and we outfitted Dr. Aruna. She didn't have to wear eye goggles. It was right on the computer. And we would put up images, and she would tell us, I see chronic inflammation over here, and you would know exactly where she was looking. She didn't have to point. And she would describe what she sees and why she made that diagnosis. So what we did was we built this framework. So now we have our artificial Dr. Aruna, and when somebody wants to train or we want to do a diagnosis, we can compare to her expertise. Next slide, please. So what we did was we have this, this is our system, and it captures, it's a regular computer, and it captures audio as well as the eyes. And then we use our engine, our adaptive AI learning engine, and it can classify the different types of chronic inflammation, bone thinning, anything else you know about dental. And then we can use it to provide service to train new dentists. But it's also a great way for all this processing. So if you have to get radiographs sent into you, it can be used as an assistive tool to say, here's what I found in these thousands of images, and you don't need to spend all that time to go through them individually like as scrutinize them as well as you would have if you had to do it individually. So we're excited to use this. It's being deployed right now for the dental school, and we look forward to seeing how our new AI trained dentists work on it. Next slide, please. So the next thing that happened was I said, built this great engine, can do skin cancer, can now do dental oral cancer. Then COVID hit. And I said, well, why not plug that engine in to help with COVID? So one of the things that happened was, x-rays are coming in from all around the world, and the quality of those x-rays truly varies. So one of the things that we worked on was, or my lab really works on, and is we can take in really lousy, poor quality images and still be able to help the AI make intelligent diagnosis. So all these wonderful AI engines that are out there and all these great algorithms are out there, they're really so data dependent. So if you're using images and they're too dark, or they're over too non-uniform lighting, too many artifacts, so much noise, blurring, that's really going to affect the quality of the classification and your determination. So what we did was we took in a set of x-rays, and our goal was to not only just detect COVID-19 versus normal x-rays, but also be able to differentiate it against viral pneumonia. So we built this system. We have our pre-processing, we do our feature extraction. I plugged in a traditional AI model, and we got some beautiful results. Next slide, please. So here's our results. So these were the only radiographs that were actually available. We use the databases that were out there, but these are the image sizes. But you can see, normal versus COVID is excellent. And again, our COVID-19 versus viral pneumonia is really good. So this is state-of-the-art results. And again, it was just putting our inventions together and knowing how to apply it and making the AI more robust. So next slide, please. So the next question is, I get a call from the Tufts Veterinary School. I love animals. And they said, we want you to, we need you to help us work on elephant projects and conservation projects. And I said, I love elephants, but I know nothing about vets. How am I going to help you out? Well, there was two issues that they have. One is they do a lot of manual data collection, and when they do that, they put themselves at risk, but it's also very expensive to do that. And then there's a lot of data that they accumulate, videos, images, measurements, all these different things that they accumulate, and they have to manually process that. So that was one thing that we could help them with. But the second piece was looking at how they capture the information. So if you move to the next slide, please, I'll show you some stuff that we've done. So one of the things that we did was we decided, using the Tufts Elephant Conservation Team, TICA we call ourselves, we actually collaborated with veterinarians and wildlife conservationists to use drones to identify elephants. On the left one that you just saw, identifying one elephant really wasn't a problem, but identifying multiple elephants in a group, especially when they go behind one another, that's another problem. But if you're using drones, you're overhead. So how do you identify an elephant overhead? So this was something that we did. We wanted to not only track the elephants to be able to see their range, but we wanted to be able to help these reservations, conservations, and park rangers do conservation and be able to detect poachers early on. So that was one of our big projects. In the middle here, you see deer. Well, deer, they can introduce disease, they can have overpopulation, they're on roadways and can get hit by cars and cause danger to human beings as well. So one of the things that we noticed that the veterinary team was doing is they were going out and they would have to physically anesthetize the animal and put it down and do its measurements to get all these different dimensions to determine the health and track these animals. So that can introduce disease too, right? Because now they could be kicked, they could be hurt, but they could also have diseases like Lyme disease or to carry ticks or even rabies. So that also presents a danger to the researcher capturing it. So we set up a system for them. This is a motion capture system. So when the deer comes into the presence of the camera, it records it, and it will be able for us using our AI to determine the appropriate height. And also they wanted to identify the individual deer. Now you might say, how do you identify an individual deer? Well, I also do facial recognition. But guess what? In the deer animal population, you identify them by their backside. So now I'm probably a world expert in AI for butt detection. So that's one of our projects. And now I'm really excited because this project for the elephants is being deployed in a conservation. So you can move to the next slide, please. It's actually being deployed, and we're really proud that it's going to be used to help help track these animals and also their health. So we use drones, but the other thing that's capturing here is not just images. One of the things that I also recognized was, you know what, it's okay to track the animals, but most drones that are flying over the animals, by the time poachers get there, are there and the drone sees it, it might be too late to get there and have an intervention. So one of the things that I decided was, well, maybe I don't need to just detect elephants on conservations. I need to detect vehicles. So if a vehicle or people are coming on, I can detect that and provide early intervention by saying, there's a truck that's coming onto the conservation that's not authorized. So these are some of the features that we decided to put together to help build this system. And we are supposed to deploy this to an actual conservation soon. So we're excited about this project. The next project, we'll move to the next slide. So I mentioned I can detect deer. I mentioned I can detect cars and trucks. And one of the things that I decided was, there's a lot of deer on roadways. That's how I thought about this. But again, motivated by real world incidents, I decided, why not try to use this for traffic? Right now you think of AI being used for self-driving cars, but I thought about it as, there's two major problems. There's information overload. And the other one is being able to detect certain incidences that are of high priority or very dangerous situations. So this is an example of a monitoring station within like a federal highway office. So we worked with the downtown Boston Department of Transportation. Their wall of screens is like immense compared to this, but that's an example. And in the state of Massachusetts alone, there's already over 100,000 cameras mounted on highways, tunnels, bridges. They're everywhere. So you have these cameras, but guess what? You've only got one or two individuals in these control rooms. No human being on earth can, possibly comprehend all that live video feed coming in at once. So this is a natural synergy for artificial intelligence to assist the human being to say, I see these conditions arising, here's an alert. And then the other thing you need to know is 50% of all the calls made for assistance from the highway department, they send out these resources, and by the time they get there, there is no incident, or it's already resolved itself. That's a very expensive proposition. So if we could have better detection and intelligence of robust to tell us with certainty that these things were real and what the severity of it was, that would really be significant. So let me show you what the Department of Highway was really interested in, how I got involved. Next slide, please. So one of the things we developed is we decided let's do a detection and tracking of objects. And on this list, you see cars, trucks, bicycles, motorcycles, pedestrians. Well, you can also include deer and elephants. So if an elephant crossed over, I would also detect that as well, because I imported some of the engine works that I did from my previous one. And I'll show you how that actually came out useful. And then we create a user interface, and we're going to be able to detect all these different, what I call anomalies. So we want to be able to look for pedestrians, bicyclists, and wrong way drivers. Next slide, please. So this was actually on TV, and this is what got my work in this research going, is I saw this on TV where they had all these kids on bicycles. If that were my kid, I'd kill him. But here's a bunch of kids in the tunnel, and if you watch the video long enough, one of the kids on the outer almost gets hit by a car. It's dangerous. It's very dangerous. So if we could have early detection that these incidents are going on, rather than having people call in and say, oh, there's a bunch of kids on, on bicycles in the tunnel, or there's a human walking in a tunnel, that's really important. Now, most of the tunnels are the most highly sought place that they focus on looking. Why? Well, because the cameras are in a controlled environment from the weather, right? Because they have controlled lighting, they don't have to worry about the weather. So it's easier for them to monitor these types of sensors or these types of cameras. Whereas on a highway, you have snow, you have rain, you have frost, nighttime. And that's the beauty of my team's research, is that it doesn't matter whether it's at nighttime, it doesn't matter what the weather is. We can help the human see and detect these incidences regardless of the quality or of the image. So if you move to the next slide, please. So this is one where my AI failed. I want to show you my failure. So you notice that's coming up and it's saying that's a bicycle. So when I first saw this, I said, well, what is that? That is a person in a wheelchair. So even though by my students and my standard was like, oh, we have a misdetection, this would come up and alert somebody that there was a bicycle in the tunnel. It's actually a wheelchair, and that's something that they do want. So you can see that there's unanticipated scenarios that you might not train for, but somehow, we've done a good job that we can anticipate some of these things. Now, most of the times, the things that AI fail in is that they will tell you or alert you to incidences, like I said, that you're not interested in. So one of the biggest challenges right now for bicycle detection in previous competing methods is that they were detecting motorcycles when they were actually bicycles. So that's why our expertise in this, we have really good specificity in this and recall and the ability to make accurate diagnosis and for bicycles versus motorcycles. And now you see some of these bicycles have motors on them. So it's becoming even more challenging problem, but we've met that challenge. So I'm super excited to announce that we are the recipient of an almost $1 million grant from the Federal Highway to finish this project with the Department of Transportation in downtown Boston, excuse me. Next slide, please. This one is another one. You can just play this one. This is another example. This one's showing a bicycle and that would send an alert. And then you can move to the next one. These people are crazy. I don't know why they want to go in the tunnel, but so that's one thing. The next one. This is the big one. This one, again, it came up quickly, but there was a little red box that said wrong way driver. And this is important because you can see how devastating it is when there's a life lost because of either somebody going down the wrong way. And part of the problem with this is, can you detect them fast enough? And usually they can't, because nobody's monitoring these cameras. So we developed a system that is not only adaptive to Boston construction, so you can see if we decide to change the direction of the traffic, our system adapts to that. Now on the right, when I first included this was a video as well. And when I first put this, everybody up said, that's a really lousy picture. Let's not use that in your presentation. And the reason I put this up is just for that exact reason. It's taken at night. It's really not a good image, but we still do great detection on wrong way drivers or people driving the wrong way or bicycles, even under these environmental conditions. Next slide, please. So, I've talked a lot about AI in this different types of applications. Right now, where my team is working on cervical cancer, again, plugging in the same engine to work on cervical cancer. I work with the School of Nutrition, looking on helping to automatically look at food and be able to tell you the calorie content of it and the nutrition value of it just with an image. And that's kind of unique in its sense, because anybody who's ever been on a diet, the first thing they tell you is, oh yeah, you should write down and track what you eat, and nobody likes doing that. But it's a great opportunity for us to also investigate using AI what I call disparate sets of data. So right now, cognitive impairity of aging populations has links to nutrition. So there's no, how do you look at obesity versus aging across the different ages of populations when there's so much data out there and none of the fields actually talk to one another, or there's so much data that you can't really explore it. So the future of AI to me is that we are going to be able to explore these diverse areas and make connections across areas to find these links so that we can come up with better interventions and explain the phenomenons and the diseases and find cures. Now, the next thing I really need to say is we really need to understand how these decisions were made. You hear about a lot about fairness and bias and algorithms. One of the things that people always ask me is, they think it's a black box. AI is this black box. You put data and it magically tells you the output. And I always give the examples about, it's only as smart as the data you train it with. So this is going to be a big need in the future. And then finally, everybody's going to need AI. We're going to need AI education. So here at Tufts, we're trying to develop AI education, not just for the engineers and computer scientists or people in science. It's going to become like a word processing tool. You're going to need to know it, and you're going to need to know why it's coming up with these decisions in order to have trustworthiness and robustness. So that's my vision. On the right, you see the cartoon. It says, "Just as I thought, you have bones." That's what I don't like about AI today is don't tell me, it's yes or no. I need to know if you're going to be the expert, tell me why and explain how this came about. So next slide, please. This is just an overview of all my lab, all the different projects we're working on. So if there's any project you're interested in. I do have the world's largest multimodal database of faces that's being used now for masks. We have one with masks on it, and we do lots of fun stuff as well. But any problem that's out there that's affecting the real world, I'm interested in it, and we love to collaborate. So with that, I want to thank you for your attention, and we can move to the next slide, and you can see how these are my adventures around the world. I got to meet President Obama. That's Neil Armstrong. He came to our Tufts graduation, and on the right is the first female president of an African country, Joyce Banda, and I had the honor of being her STEM advisor. So my research has opened new doors around the world for my students and our Tufts community to make impact on lives. And I think that that's where your support has really made an impact for us. So thank you again, and I'd be happy to entertain any questions at this time.
All right, thank you. Thank you, Karen, for the fascinating talk. Let's open the floor for questions. Please do submit your question through the Q&A tab in the bottom of your screen, and I will read them by the order they come through. Karen, are you ready?
I'm ready, let's go.
The first question is, can you use your traffic incident detection work to help regulate traffic by controlling the traffic light system to prevent blocking the box or cars having a green light when they cannot move?
So I can detect it, and we could definitely, using like Internet of Things, we could communicate to the lights. The problem is, unless it's a self-driving car that we can control, you can't control human beings. And I'll give you an example of that. One of the things during our investigation that we were looking at was how many people drive on Storrow Drive in trucks. And they can't get under that bridge. And even though it says you're over height, and they looked at flashing lights and all these other things, they even put down walls of water. So a big, waterfall would come down to say you're over height. You can't stop human beings from doing stupid things. So we can detect it. And one of the things that you could do, which I think would be effective, is if you do block the box, then we detect it. You can't send an automatic ticket out because you can detect the car. So I know some states are actually doing that for people that run red lights, but we are looking at this to detect the onset of congestion. So that's one way we're looking at congestion and trying to identify better ways to help the Department of Transportation mitigate or anticipate how traffic congestion, understanding, what are the mitigating factors that cause it, not if it's not an accident. And so we're working on that, but block the box, I think we're stuck for a while until people aren't driving the cars themselves so that they follow the rules.
Thank you, Karen. The next question is, I have college and high school aged children. In what academic areas should they get involved if they are interested in working in AI field, such as should they go to math, engineering, etc., or any humanity field?
Well, you got to remember, I'm here with my boss, Dean Q, who's the Dean of Engineering. If I say anything but engineering, right? So I think one of the really interesting things, I wrote a book on how to engage children in STEM. It's called Count Girls In, but it's really how to engage students into science and engineering. The real question is, if you want to get them interested in this field, is to connect what they like. So, if they're interested in nutrition or exercise, then all of a sudden you want to say, okay, I want to use AI for, and you think of a social impact. If you can connect their interest to a social impact, then the tools that you need to enable them to experience and explore that discipline are really there. Now, of course, engineering is all about taking the science and being able to explore these areas into realizable, executable types of applications. So I usually tell people, engineering is a really great field. Math, and that's one thing I really want to bring up too, is a lot of people say, well, my kid's not really great, or nobody's gonna say the kid's not really great. All kids are great. But a student will say to me, I'm really not good at math or physics, so I can't be an engineer and I wouldn't be able to do these impactful types of things. And I want that mindset stopped. That's a filter that's absolutely untrue. Is that, math and science are a toolbox, but if you can get into engineering, and it's more important that you can connect the fields and can foresee some innovation or see how to solve problems, even if you don't know the math and physics to solve it. If you can envision a solution, that's really the key to being a true engineer. So that's really what you have to connect them to. But engineering, we'll teach them the math, we'll teach them the physics, and don't let them be scared off by that.
Thank you, Karen. The next question is, how much coding work there is for each of these projects?
So, and everyone is different. So when I first take on any project, students, if I come in and I say, you're going to build an entire traffic detection system that's going to be able to take in 100,000 cameras and sensors all around the state. And, and I present that to a student, I'll watch their face drop and shake, and they'll just sort of, crawl at the door. So one of the things that we need to do is we need to structure the problem so that we break it down for them. And that's how you engage them. And upon one success, they have another. So in these projects, I mentioned that I use some off-the-shelf artificial intelligence networks. And I think in the future, it's going to be a toolbox where you'll say, okay, here's this deep learning algorithm. Here's how your data needs to be. Here's how you phrase your investigative questions. And here's the different, what categories you're looking for out. And it will allow you to do that. So there's a lot of off-the-shelf pieces out there now that are available. But for us, we do a lot of our coding in MATLAB or Python or C++. So the coding, my students do need to know how to code, but a lot of my I would call them pure electrical engineers, they don't like coding. So they use a lot of the toolbox things. So it really varies based on the students and the project that I give them. But most of them, I would say the biggest coding that we've had to do is most likely for the dental project, because I had to code a user interface. I had to use, take input in from an eye tracker. So you have to be able to interface with different sensors and be able to write the interfaces. So that's probably the most heavy duty one that we've done.
Thank you. Next question. What do you think about Elon Musk and his unleashing of self-driving cars? Is the technology ready?
This brings up a huge question, because for drugs, right, and anything that we consume as human beings, there's a huge rigorous testing protocol that goes through it. The problem right now with a lot of new artificial intelligence, including self-driving cars, is that the testing protocols that were put in place, that are currently in place, are really not fully explored. And, what an example is somebody saying, well, if I put a human being behind the wheel with a self-driving car, that it'll be safe. Well, we've now seen that's not true. There are always conditions and scenarios that will break any program. So the question is, how do we come up with more robust testing? What are the protocols and standards? So right now, there are no standards for testing artificial intelligence applications. And the ethic, right now you see a lot about ethics, but there's got to be a lot more standards there. So we need to be able to, one of my fortes is I break things. We have to be able to not just look at how things are supposed to work, but then stress test them to see how they're not supposed to work. So, I crossed the Tufts intersection. I'm like, wow, I wonder if a self-driving car could look at this massive crosswalk of white and black and all these different shapes and still be able to function. There's so many variations that need to be tested. So until standards come up, and that's a whole new field. I think that's going to be a whole new field, is just how do you come up with standards for artificial intelligence, any system that includes artificial intelligence?
Thank you. Karen, the next question is, most of the applications you showed are yes or no or categorization, except estimating the size of a deer. Does the size of a deer problem requires a fundamentally different engine?
Yes, it does. The other one that we do, we have the categorization of all the different dental ones. That's probably got like 12 different categories. But you're right, we don't have specific bins per se for most of these things have bins and say, it's one of these 8 grades of cancer. It's one of these 12 chronic conditions in the dental condition. The deer was an interesting problem because not only were we looking at the dimensions, because the dimensions is uncertainty in there, right? Based on the measurement you take, the camera angle, that we had to really set up we had the motion sensors set up for the cameras. All of a sudden, the distance from the camera made a difference, because if they're far away and I the perception of the perspective made a difference. So we had to really do some intelligent modeling, I will say, to not only take in the angle, the orientation, and we had to look at depth as well. So that was harder. And then you have there's always a margin of error. So we had real data of deers that had been tied down and, measured by hand. And they're also looking, by using those measurements, determining the weight and also the health of the animal. So, it was a much more, I would say, in-depth analysis, and just being able to capture from the sensors. I can't just take the image and say, yeah, it's a deer anymore. I actually have to know those things. So we had a lot more, I would say, scholarly contributions in developing those models. And that wasn't just a plug-in. So that one was not a plug-in. That one was actually custom.
Thank you. Next question. In what areas, if any, aside from mere number crunching of huge amount of data, do you think AI can surpass human intelligence?
Personally, I think that until we can capture emotion or ethics in machines, I don't think it will. That's why I always think it's going to be an assistive device. However, I do think that its biggest advantage to us is going to be in exploration. So whether that's underwater or whether it's space exploration, I think it has the capacity to, if we can build AI AI to AI that can learn from one another, repair one another, and also be able to make inferences based on the sensor data. I think that that's going to be where it surpasses us, because it will be able to see things that we, can't interpret. We just right now, if you think about a neural network, there's so many different things that are going on inside. It's picking up things that we can't see. And I always give the analogy of sensors, of camera sensors. There's so much in an image that the human eye can't perceive. And there's there's a lot of information there, and it probably knows, but how do you bring that out to light? So the big challenge is there's so much more information that's there that it knows or has. How do we visualize that and interpret it for human consumption? that's really where the challenge will come in. But surpassing humans, I don't think that we're there, and I honestly don't think we're going to get there.
Thank you. Next question is related to this. AI for sure is a way of the future. Your work is incredibly valuable and powerful. It seems to me that with this value comes the responsibility to teach moral integrity in the application and use of this technology, in addition to teaching how AI works and how it is used. Is the responsibility and moral integrity part of a Tufts thinking in educating students in this exciting area of research?
Yes, one of the interesting things about this is that we're always learning. So, I mentioned all the different projects we do. A lot of them, students learn about institute research protocols or board certificate things where, the whole principle is do no harm. So students never think about that. Like when we were doing the dental project, we were working on one, and my students were testing the devices in their own mouths and things like that. And Dr. Aresh came and said, no, we don't work like that. So they learned that, no, there's a safety protocol, but there's also ethical considerations, because we want to make sure that if we're using these devices that we're not, exposing you to chemicals or hazardous radiation or anything else. And part of it is not just the safety factor, but it's also the impact of what we're disseminating. Because if we go and we disseminate a result that could be very impactful or hurt a community, if we make the wrong assumption, or something comes out wrong, or we inadvertently bias something, like I think you've seen the news, like a company trying to hire the best candidate, and it ended up that women were excluded. So you have to think about all these considerations. And again, it comes down to not just solving the problem at hand, but envisioning how will this have broad impacts, not just for the community that you've designed this for, but for the environment, for for the future, for children, for all ages. And really, that's something I think that we need lots more work on. I'm not an expert in it, and I think that we're trying to bring it into our courses, but we really want to build this expertise and have it not just, I know a little bit, a little bit. We really want to focus on how to integrate that across our institution. Great question.
Thank you, Karen. There are still a number of questions that we have not been able to get to, but the time is up. We need to stop here. Thank you, Karen. What a fascinating and exciting presentation. And to all our alums, parents, and friends around the world, we appreciate you joining us and submitting thoughtful questions. You will receive an email in the next couple of days with a link to a brief 2-minute summary, which I hope you will complete to learn more about upcoming virtual programs hosted by the university, such as Tufts Talks on October 27. Please visit alumandfriends.tufts.edu. And we will try to answer some of the questions that we were not able to get to now, and through either email or other ways. Thank you for joining us. Have a wonderful rest of the day, and please be well.
Thank you.
Thank you.